Welcome to all of you in Physics की दृष्टि. Today we will discuss B.Tech Engineering Physics important questions. These important questions are very important for your end-sem examinations, and each question carries 2 marks. So this video is only for 2 marks question. Next video is for 6 marks and next video for numerical questions. So let's start our 2 marks questions. Our first question, write the full form of laser and mention two characteristics. 2 marks, then full form and characteristics. So what is full form? Everyone know L stand for light, A stand for amplification, S stand for stimulated, E for emission and R for radiation. So full form is what? Light amplification by stimulated emission of radiation. And these are the 4 characteristics. You can write any two. Okay. So light is a highly coherent. Highly coherent, that means what? All waves are in a same phase. Second, laser is a highly monochromatic. Highly monochromatic, that means what? Only a सिंगल कलर. ठीक है, ग्रीन है तो ग्रीन है, रेड है तो ओनली रेड, येलो है या ब्लू है तो ओनली ब्लू, सिंगल कलर. थर्ड, लेजर कैन बी अ डायरेक्टेड टू अ डिस्टेंस ऑब्जेक्ट एंड ट्रैवल एज अ पैरेलल बीम. उसका जो स्प्रेडिंग है वो बहुत ही लो है ऑर्डिनरी लाइट के मुकाबले. एंड द लास्ट, लेजर एमिट्स अ लाइट बीम इज वेरी इंटेंसिव. इसकी जो इंटेंसिटी है वो बहुत क्या है, ज़्यादा है, और ऑलवेज स्टे कांस्टेंट विथ अ distance unlike a ordinary light. So these are the 4 features. You can write any 2 or 3, it is enough for you. Next question. Our next question, very important question. Difference between spontaneous and stimulated emission. So always remember one methodology. Spontaneous, that means what? Spontaneous, that means itself. And stimulated, that means what? Stimulated, that means we need some external sources. Remember, whenever we are delivering the lecture, these are the important points. So you can write any 3 or 4 points. Now it is enough for your 2 marks. So let's check one by one. First thing, spontaneous emission was uh, postulated by Bohr and stimulated which is postulated by Einstein. वो किसने दिया था? तो इन दोनों ने दिया था. Next is additional photons are not required because it is itself. But here additional photons are required because the external thing. Here only one photon emission is happen and here two photon emission is happen. Emitted radiation is polychromatic, that means multiple wavelength is here. Here is monochromatic, only single wavelength. These light is incoherent because ordinary light or your simple light, these are the coherent light, लेजर लाइट. ठीक है, और उसके एग्जाम्पल लिख दीजिएगा. लाइट फ्रॉम सोडियम मर्क्यूरी लैम्प एंड दिस इज फॉर लाइट लेजर सोर्स. सो दीज आर द डिफरेंस. नेक्स्ट क्वेश्चन. Question number 3. What is the role of helium in HENE laser? So first question is what? What is the role of helium? And then state 2 applications. Any 2 applications are needed. So the role of helium is what? The role of helium is excite the neon atom to cause a population inversion. This is the main role of helium in helium-neon laser. What happened at that time? So one of the excited level of neon is this much, and which is nearly the same level of F3 helium atom. So therefore what happened? Whatever energy can occurs between excited helium atom and the ground level of neon atom, whatever the kinetic energy of helium atom na, that provides the additional 0.5 energy required for a excitation the neon atom. And this occurs what? This occurs population version, and when the collision happens and again helium will come to the ground state. Okay, so this is the main role of helium atom. Our next question is what? State 2 applications. So you can write any 2 application like holography or optical alignment or it is a continuous wave, so that is using for printing or barcode and etc. Okay, so this is a simple answer of our question number C. Next question, why semiconductor laser is much preferred? So here they are asking why. So always why question is answer what? Advantage. Because semiconductor laser is compact in a size, it has a highly efficiency or high efficiency, low operating voltage, and the most thing is cost effective. So these are the advantages. That's why you can simply write semiconductor laser is a much preferred over other lasers. Simple question, simple answer. Next important question, what is the black body? Give an example of a black body. First is the definition, an ideal body that absorb all kind of radiation which is incident upon it regardless of frequency of a radiation, it's called a black body. हम जानते हैं कि एक ऐसी आइडियल बॉडी जो सारे रेडिएशंस एब्जॉर्ब कर देगी जितने भी उस पे पड़े हैं, उसको क्या बोलते हैं? ब्लैक बॉडी. एंड यू कैन राइट दिस अनदर लाइन, whatever black body na, the absorb the radiation, since the body at a constant temperature in a in a thermal equilibrium, its surrounding, it must be absorb the energy from them and the same rate as emits the energy. जितनी भी एनर्जी उसने एब्जॉर्ब की है वैसी ही उतनी ही एनर्जी वो इमिट भी करेगा. वैसे बोलते हैं ना कि ब्लैक बॉडी इज अ गुड एब्जॉर्बर एज वेल एज गुड emitter also. So this is the definition of the black body. An example like the sun or the graphite or carbon mesh, or another example is ferrous black body. So just go with these three example. You got 2 out of 2 marks. Next question. Next question is, state the Stefan Boltzmann law and Winds displacement law. Two laws everyone know. Stefan Boltzmann law is energy is proportional to T to the power 4. This is the Stefan Boltzmann law. The energy radiation emitted from a black body at a temperature T, which is given by this. This is what? This is a Stefan Boltzmann law. And just remove the proportionality sign. What we have E is equal to sigma T raised to 4. Sigma is what? Sigma is the Stefan constant, 5.67 10 to power minus 8. And second question is what? Winds displacement law. Everyone know, with the increase the temperature, the wavelength lambda maximum is decreasing, where lambda m, that means lambda maximum is the wavelength of which energy emitted is a maximum. So lambda m, which is proportional to 1 by T, and just remove this proportionality sign, lambda m T is equal to constant, and this constant, that symbol is B, and that B is what? That B is a Winds constant, and that value is 0.28 centimeter into Kelvin. So this law, that name is what? Winds displacement law. So just write 2 statement and 2 equation, you got 2 out of 2 marks. Next, what is a ultraviolet catastrophe? Very important question. The energy was calculated for a longer wavelength. First of all, this is the Rayleigh-Jeans law, and just check this equation. Energy which is inversely square proportional to the wavelength. तो इसके मुताबिक क्या होना चाहिए कि भाई जब वेवलेंथ जो है वो इन्फिनिटी तक जा रही है तब एनर्जी क्या हो जा रही है? जीरो हो जा रही है. सो दिस इज अ correct. But just check this another contradiction. What happened? This energy spectrum graph, the formula, this formula, Rayleigh-Jeans formula, agreed for a longer wavelength. It is okay. And goes forward infinitive at a shorter wavelength. But यहाँ पर फॉर्मूले के मुकाबले क्या होना चाहिए? हमारे ब्लैक बॉडी में होना ये चाहिए कि वो जीरो की तरफ जाना चाहिए. But here the contradiction is what? For a shorter wavelength, it goes to the infinity. And these contradiction came to notes as a ultraviolet catastrophe. Got the idea? So graph presentation is good for you also. This line is represent the ultraviolet catastrophe, and this line is what? Original of the black body radiation. Next, Next, what is the photoelectric effect? So in this photoelectric effect, just draw a very rough diagram metal, and whenever light falls on the metal material, electrons are ejected from the metal surface. That is the law. When the electromagnetic radiation, that means light of a high enough frequency incident on a metal, electrons are emitted from the surface. This phenomena called as a photoelectric effect. And whatever currents we got, that is, or whatever emitted electrons, that name is photoelectron, and that current name is what? Photocurrent. And in question they are asking, write the Einstein photoelectric equation. So this is the Einstein photoelectric equation. H nu is equal to h nu 0 plus 1 half mv square. This is the phi work function. H nu 0, that is the required thing. Sorry, this, yeah, okay. 1 half mv square. Remove it. Clear? So this is the formula for a Einstein photoelectric equation. Minimum requirement energy, that is phi. Next question. Heisenberg uncertainty principle. Everyone know it is impossible to determine the position and momentum of quantum mechanical particles simultaneously with the perfect precision and accuracy. This statement is what? The statement is Heisenberg uncertainty principle. And mathematically representation is what? The product of the uncertainty and simultaneous measurement of the position and momentum. Let's suppose the position uncertainty delta x multiply with momentum uncertainty delta p is always greater than or equal to h cut by 2 pi. And h cut, that means what? H cut, that means h upon 2 pi. So just put, we got this. So our final equation is this. Just write this equation, you got 2 out of 2. This is our Heisenberg uncertainty principle. Next question, 10th one. What do you mean by eigenvalue? Okay, very good question. An eigenfunction and gives the mathematical expression for momentum and energy for a one dimension. So first of all, what is the eigenvalue? So write down these definition. When a operator acting on a function always a product the same function multiplied by a constant factor, the function is called eigenfunction and the constant value is eigenvalue. Got the idea? Suppose this is my function f of x. Okay, whenever you operate something, let's change the color. I am operating this a operator. So this is what? This is sorry, yeah, this is the function, and whenever I am operating something, suppose a is my operator, so what we get? We get a one constant value. Suppose c is a constant value, and again I got a same function, this one. So this function is called eigenfunction, and this value, whatever value we got now, that value is what? That value is eigenvalues. That's why this is the equation. And what they are asking, write the momentum and energy. So this is for momentum operator, delta px is equal to what? I minus I h cut del by del x. Or energy operator is what? E is equal to I h cut del by lt. These are the energy and this is the momentum operator. Simple question. Next, 11th. Define the Compton effect. Compton effect क्या है? Very simple. Again, figure is very important. Those who have a figure and formula and figure are very important. Okay. If some definition is some contradictory statement or some error na, then figure and formula marks are given. Okay. क्या है Compton effect? So whatever shorter wavelength, whenever incident upon this particular things, what happen? The scattered wavelength is already always change, or ye initial wavelength and whatever scattered wavelength both are different. Okay, this effect name is Compton effect. When the monochromatic beam of X-ray of a wavelength lambda allowed to incident scattering material, the beam scattered contains the radiation of longer wavelength. Whatever scattered, that is a longer. Lambda dash is a longer and lambda is a shorter. The difference between these lambda dash minus lambda, that is Compton shift, and the effect depth name is what? Compton effect. So whatever lambda dash minus lambda is what? Is h by mc 1 minus cos theta. And always remember, the Compton shift does not depends on its wavelength or its incident radiation or the scattering material. It's always depends on the scattering angle only theta. Clear? So this is all about the Compton effect. Next question, classify the solid material based on the band structure. See, based on the band structure, there are three classification: conductor, semiconductor, and insulator. Everyone know in conductor overlapping bands are there. In semiconductor, there is a small gap between valence band and conduction band, and in insulator, there are the wide band gap. Here I have no space, that's why my diagram in a next slide. Otherwise, diagram is a very important thing for these question. So first of all, let's go with the conductor. Conductor has a high electrical conductivity like copper or silver. Semiconductor has a conductivity but moderate, low compared to conductor and high compared to insulator like silicon and germanium. And insulator very low electrical conductivity like diamond or glass or quartz. But in this question, in this answer, diagram is very important, and the diagram is this one. So that's why I put a diagram here. Insulator, just check the gap, which is very vast gap. Conductor, conduction band and valence band gap. In a semiconductor, the gap is there but very low gap. And just check the conductors, there is no gap, they are overlapped. That means zero band gap is here. So just draw the diagram for the previous questions. Next question, this one question, what do you mean by valence band and conduction band in solid? So only definition they are asking. What mean by valence band? The energy range where electrons are bound to atoms from the chemical bonds normally filled with electrons. They cannot move freely, so they do not conduct the electricity. Simple. Conduction band is what? Energy range where electrons can move freely, conduct the electricity. Very simple. And what is band gap? The gap between valence band and conduction band. That is what? Band gap. Simple question. Our next question is same. What do you mean by band gap and why it's called a forbidden? Very simple question. The gap between top of the valence band and bottom of the conduction band, that is band gap. And why it is forbidden? Forbidden, that means what? Electrons cannot exist within the energy range under the normal condition. That means suppose this is a EC and this is the EV. So between these region and there is no energy level, electrons cannot exist. That why that name is what? Forbidden. Got the idea? Next, 15th, write a short note on p-type and n-type semiconductor material. Very simple. P-type semiconductor material or a semiconductor doped with trivalent like boron and gallium, then we got what? P-type semiconductor. And if it is doped with the pentavalent like phosphorus or arsenic, then we got what? N-type semiconductor material. In mechanism, holes can move and act as a positive charge. Here electron can move and act as a negative charge. Charge carrier, majority are hole in p-type and minority electron, and same inverse. N-type, majority is electrons and minority is hole. It is enough for a 2 marks. Got the idea? Next, draw and explain the EK diagram. So just draw this simple diagram. This is your energy on y-axis, this is your momentum vector on x-axis, and just draw this line, that is your EK diagram. Okay, so what is EK diagram? EK diagram, that means E for energy and M for momentum vector, is a graphical representation of used in a solid state physics to illustrate the relationship between energy of an electron in a solid material, their momentum, which is related to the momentum vector k. And what are the significance of EK diagram? So first write these three significance. Give the energy and momentum relationship for an electron, useful study band structure, gives an idea of a band gap. and then you can write these things: significance of EK diagram, understanding electron behavior. Like EK diagram helps in visualizing, understanding how electron behaves in a different material, especially how they transition between energy state and how it's affect the conductivity, band gap, and electronics property. So these are the significance of the EK diagram. Now you got 2 out of 2 marks. Next question: define the direct band gap and indirect band gap. Very simple question. You can use the simple figure like this. Suppose this is the y-axis and this is your x-axis. So just simply you can draw this and this. Okay, and just draw this line. So go with the diagram. If top of the valence band and bottom of the conduction band at the same level, same k value. So that means this level and this level. According to this figure, this level and this level both are at a same space, same k value. That is direct band gap. And you can draw like roughly here, like this and this. So see, this value and this value both are not in a same space. That means different k value. That is what indirect band gap. Here what happened? K does not change. That means momentum does not change. Momentum is conserved, and here due to k change, momentum is also change for indirect. For direct, examples are what? Direct band gaps are quite useful for optoelectronic like laser or LED, and indirect are not using for a optoelectronic device. Some example is given like silicon and indium arsenide, gallium arsenide for a direct, and indirect silicon and germanium. Got the idea? So 3 points for direct, 3 points for indirect, and example. Your question is done. Very simple question. Next question: define the density of state. पहले उसको define करो. Then write the mathematical expression for free electrons, valence and conduction band. Very simple question. Everyone know density of state is what? The number of electronic state available per unit energy interval at a given energy level. It is crucial in determining the electronic properties of material, particularly in a semiconductor and matter. Just remember these equation for a free electron density of state. G of E is equal to 1 by 2 pi square 2m h cut square raised to 3 by 2 e to the power 1 half. Now for conduction band, see, everyone know this is conduction band, this is energy E, this is EC. So what is the energy E minus EC? So just replace this E minus EC with this E. So just replace, rest of the things are same. Just replace this E minus EC raised to 1 half. That is for conduction band. And what is for valence band? This is EV and again this is E. So it become EV minus E. So just replace E to EV minus E. Again that is for a valence band. And this is for a conduction band. All equation are same. Just remember only this equation and replace the energy value. Very simple. Next question: write a short note. These short notes are very important. Let's check one by one. First thing is agglomerate and aggregate. Everyone know agglomerate that means weakly bound, and aggregate that means strongly bound. 2 marks question, only 2 lines. You got 2 out of 2. Next, 1D, 2D, 3D example. Like 0 dimension is nanoparticles or quantum dots. Figures are important. You can draw like some particle. 1D nanowires or nanorods or nanotubes. जैसे मैं line बना रहा हूँ, that is also nanowire. Okay. 2 dimension like these thin film on multi-layer coated sheet like this. And the third, that is a bulk material, which is a third layer. Next, short note: solar cell or PV cell or photovoltaic cell. Again, figure is very important. What is photovoltaic cell or what is solar cell? Are semiconductor. Sorry, photovoltaic cell or solar cell are a semiconductor device that converts sunlight directly into a electrical energy. They play a crucial role in generating a renewable solar cell. Again, go with this diagram. Whenever sunlight hits on the material, electron hole pair EHP generation happened, and again electron attracted towards to the positive and hole attracted toward to the negative. We got some current. That's why they are writing a semiconductor device that converts sunlight into a electrical energy. So the device principle is what? PV cell involves the interaction of light with semiconductor, the generation of separation of charge carrier, and creation of electronic current. Very simple. You can write application like residential solar, commercial solar, solar power plant, solar batteries. It is enough for a 2 marks. Next question, optocoupler, very important. First thing is what? LED. Second thing is photodiode. There is no connection. So optocoupler is an interface between two circuits. This is the definition. Opto, that means light, coupler, that means to connect. Here two circuits input output are connected optically instead of electrical connection, and can be employed where a signal must be passed between two circuits without electrical connection. There is no connection. Only what happen when LED will glow, that light falls on the photodiode. Again photodiode receive the light and again converting into a current. So first current which is converting into optical energy, that means electrical energy which is converting into optical energy, and again optical energy which is converting into a electrical energy. So there is no electrical connection. So advantage is what? Prevent unwanted electrical interaction between input and output, and this is useful as a on off circuit also. So this is all about the optocoupler. Got the idea? You can write these things for optocoupler. It is enough for you. Next question. सॉरी, एक क्वेश्चन चला गया, कोई दिक्कत नहीं. शॉकी जंक्शन and ohmic junction. Schottky junction, first thing, this is the Schottky and this is the ohmic, already written. Remember Schottky, which is a, this is the lightly doped region and this is the tightly or heavily doped region. Clear? So Schottky junction is a in a metal and connect with the semiconductor n type, which is a lightly doped, and this is a very heavily doped. Simple. This junction, which is a rectifying junction, why? Because of whatever barrier width na, it is a very high, and here it is a non-rectifying junction because the barrier width is very low. So electron can easily go towards to this direction also. And what happened in Schottky junction? So whenever forward bias we got some current, but whenever reverse bias there is no current because the current is rectifying. Electron can't they are not going वो इजीली यहाँ से वहाँ नहीं जा सकते हैं, इसीलिए क्योंकि बैरियर की हाइट जो है वो बहुत ज़्यादा है Schottky में. लेकिन इसमें क्या है, द हाइट इज़ वेरी लो, so electron can easily going towards to this side. So again in forward bias it is like this, and in reverse we got some current. So it is nearly related to Ohm's law. That means ohmic junction, and here only we got a current in a forward bias, not in a reverse bias. So that's why it is a rectifying barrier or rectifying junction. That name is what? Schottky junction. Very good question in 2 marks. You can draw this figure or this figure also, and lightly doped and heavily doped, rectifying and non-rectifying. These 4 words are very important. And I think last question we have. In the last question, what is XRD? Define the Bragg's law. What is XRD? X-ray diffractometer is a device for analyzing and measuring the crystallographic structure of a material. कोई भी unknown structure है उसका अगर हम कोई भी unknown material है उसका structure जानना है तो हम क्या यूज़ करेंगे? XRD, component X-ray source, sample stage X-ray detector, And what is Bragg's law? XRD principle is Bragg's law. When X-ray incident on a crystal lattice, an angle theta will reflect back with the same angle of a scattering theta, and the path difference d is equal to the whole number, and constructive interference will occur. That law is what? That law is 2d sine theta is equal to n lambda, or you can write n lambda is equal to 2d sine theta. Here you can write lambda is your wavelength, and d that means this interplanar distance, that is the theta, that means what? Incident angle, and whatever scattering angle. So just write this statement for the Black's law and this for the XRD, and I think our 20 question is done. Just prepare these 20 questions for 2 marks category. Your maximum preparation is done here for 2 marks. Okay, so go for it. All the best for your exam. Good luck. And now wait for 2 days. Within 2 or 3 days, you got a 6 marks important question, how to write, what to write, and again I will explain for the 6 marks. And after that, there is a one video for a numerical discussion. Okay, so if you are aware with these three things now, your paper, that means you got 100 out of 100, or whatever your paper marks, 60 out of 60. It is a very 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 important thing for your end-sem exam point of view. Got the idea, beta? Okay, so subscribe our channel, that name is Physics की Drishti. Thank you for your love, thank you for your support, and always visit again. All the best, beta, all the best. Good luck for your examinations. Thank you very much to all.